I will record it. All right, so for those who don't know, I'm doing a organic, aesthetic inspired desktop water fountain. Basically, something that just sits on my desk and pumps water around in a nice, soothing, calming way. So just a little background, I guess, on desktop water fountains. You have water falling through some sort of like unique, top fountain head, I guess I'd call it. And the water falling can act as a dynamic component. And I think it's really easy to tie into organics because of the use of water already present. Oftentimes these are battery operated and that, uses a small pump to move the water around. So as far as the organics aesthetic goes, I think a big thing about it is kind of unity and chaos. It's completely random seemingly and impossibly complex, but it's guided by whatever underlying physics and that just makes these cool shapes. I think another thing that I was kind of going for to show the organic aesthetic is many diverging and interconnecting lines. You can kind of see that in the picture on the left here and the picture on the right with tree branches. And another thing I was going for to kind of show this was a supporting center component. I was really using this picture as my inspiration for most of the project, that being a view of looking up at a tree. So then to achieve this, I'm using a tool in SOLIDWORKS called topology optimization. Basically, it's iterative finite element analysis where it tries to find the maximum stiffness to weight ratio, effectively just strategically removing material. So in this load case here on the left, it's just a cantilever beam with a single load, a single fixture. And I think a big thing kind of when thinking about topology optimization is the strongest shape being a triangle. We've all heard that in like third grade or whatever. But it's pretty apparent here. The picture on the left is the output of that cantilever beam load case where this was the fixed side and the point load was here at the end. You can see a lot of triangles throughout it, but it also kind of looks organic with things branching from one point, and it's pretty cool. You can also do this with 3D load cases as well. So I did a little CAD of a triangular prism and ate away some material and got a pretty cool output from that. As you might imagine, you have to use a lot of support material when printing these. So 3D printing is really the only way I've found to manufacture these parts. But this was the fountain head, that like kind of the base geometry that I'm using. You can tell that I'm only at 60%, 40 minutes in. So, these could take many hours on each simulation, depending on the settings I was using. And it took 10 tries. So that was spread out over a couple days of almost continuous simulations. And then some identifying features here is the center shaft that runs through this component for water to come up, and then angled channels for water to flow down. Something I'm hoping for, I think the dynamic component is really going to be the water flowing, but I actually have this whole fountain head sitting on a bearing. So hopefully the water flowing down at this angle, little conservation of momentum, might cause the fountain head to spin, which might add another cool component. Here's the output of those simulations. So here, each little triangle is an element in the finite element analysis. And I was able to maintain all the mating features through some settings in the topology optimization tool, those being the place where the bearing sits, the channels, and the vertical shaft running through. So, I think it's pretty effective in kind of mirroring a tree. You have the trunk coming up and then different branches coming off and then almost a canopy draping over it. And then to do this, I kind of just mess around with arbitrary forces and torques, play around with a proportion of those until I get an output that I like. It's all for the aesthetic purposes, nothing that's actually math or science related. So here's a little cross section of the overall design of my project. You can see the fountainhead. I didn't include the topology here just since it's a pain in the ass to move around those parts once they're optimized. But I'm kind of going for a natural wooden base, I think, to emphasize the organic inspirations. And that's going to act as the housing for a small pump and battery pack. The pump connects to these little channels where water will be pumped up through, fall down, and then kind of into this dish where it's all going to collect and fall back down through this hole into the pump and repeat. And then I have a sealed bearing that's going to sit right in this gap here to hopefully allow the top to spin without water leaking out. I made sure to get a sealed bearing, but I don't really know how well those work, but we'll see. As far as construction progress goes, here's the hardware, the sealed bearing and the small pump. This is just 3 to 6 volts, and that kind of determines the pressure head. So I was going to do a similar thing with a potentiometer to literally dial in what voltage is across the pump. And then on the right here is a 3D printed output of the fountain head. I haven't done all the finishing with sanding and whatnot. I also bought this cool sealant that gives it a nice shiny surface finish on PLA. So I'll be applying that at some point. Yeah, and that's the progress I've made so far.